Alright, welcome back. MECH2320. Getting into chapter 11 here. We're going to be discussing timer relays. You're also going to have a lab where you're going to wire some of these up in a couple different labs here and get to actually work with the timing relays. Okay, so we're going to talk about the different type of timing relays and identify the symbols and kind of understand the general operation of them. Okay, so for the most part, if we're talking timing relays, we're talking an on delay or an off delay type of timing relay. So what does that mean? We've talked about it in PLCs, right? But an on delay relay means it delays on energize. So what does that mean? So when the timer closes, all right, and say it's set to 10 seconds, the timer will close and the contactor for it closes, and then it's going to start, counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When 10 hits, right, it actually energizes and starts a motor or something like that. All right, so if we have a temperature setting or something, or we got to wait for something to get to a certain point, all right, or we have to time it, that's when the motor turns on. Okay, off delay, also it delays on de-energize. So think about what happens here is, your car door. We've talked about this before. When you get out at night and you close your car door, okay, the dome light, it detects that your car door is closed, your dome light is still on, all right, and then like 10 seconds after your car door has closed, your dome light turns off. Okay, so that's a delay de-energize. So when we open a switch or cut power from something, the counter starts counting to 10 or whatever you set it to. Alright, and when it reaches that point, it de-energizes or shuts off. Okay, so that's kind of the difference between on delay and off delay. Okay, and then operations, what are we controlling? We're controlling coil connections and things like that. We're de-energizing, energizing coils. We're turning opening and closing contactors, essentially, as you want to understand, or turning things on and off as we go through it. Okay, so symbols, we should know these, from PLC class. If we've gotten that far into timers by now, if not, no worries. You will know them for PLC class because we've learned them here. So we have an on delay timer, normally open, and a normally closed. All right, so those are the symbols, the NEMA symbols. And then if we look at the next figure, figure 11.2, those are off delay. So notice the difference in, when it's on delay, it looks like an arrow going up, right, essentially, and off delay, the arrow's pointing down to off. Okay, we also use contactors, all right, in the ladder logic and things like that. So when we have a TC, that's time closing for contactors, so we'll give that a TC tag. And then we have a TO, which is time opening contactors. So that way we can distinguish and not necessarily just put like T on there or something like that. When we're doing the ladder logic, though, we got to stick with the I/O addressing and things like that, but just for relative understanding. Okay, another way that you might see these symbols is NOTC. Okay, normally open, time to close, and normally open, time to open. All right, so those are how you're going to see those symbols when you might see them. Okay, and the symbol piece really doesn't change. It's just kind of the tagging piece, okay, whether we have on delay or off delay. Okay, different other types of timers are pneumatic timers. We talked a little bit about these in fluid power, not extensively, but how they really work, right? It looks kind of like an accordion type scenario there, okay, but we want to restrict the flow of air, and based on us restricting the flow of air through the orifice, right, just a hole for it to escape, based on how fast we let the air out is how fast that switch will actually close, and it'll be timed based on how fast it takes the air to escape. So you can see that that's kind of just a big diaphragm there that's holding air, and as we open and close it, all right, so we use a rod to extend or retract and that sort of thing, but then we allow the air to escape, and the air is the timing. So the timing has to do with how fast you let it escape with the needle valve or things like that. Okay, so there's where our pneumatic timer comes into play. Clock timers, all right, this is a little bit old school picture here, right? But AC synchronous, all right, we have clock timers. just different measurement and things like that we might want. So this one's clock driven for each one. Obviously manual, kind of old school sort of clock. Okay. We have cam or sequence timers, so when we want different operations to be done in a specific order on a shaft or things like that. So these are definitely done where we have to have, remember sequence means this has to happen, then this has to happen, and then this has to happen. So we have to be able to go in order. So we want to make sure that the timing is correct on how all those hit. So if we have something, look at the cam on the shaft there and how it's rotating and when those hit. So it's about timing and all those sort of things. Okay. We have electronic timers as well. You'll have, I think we got one of those on one of the labs as well. Most of the stuff we're going to use is the pin timers. Okay. But these are solid state components. Remember, anytime we hear the word solid state, I want you thinking like our digital electronics classes. We're using transistors and things like that. We're using MOSFETs, BJTs, those sort of things inside of them. So, those are just all literally, circuit boards in there doing all the controls. And you guys, we've made some timers and things like that. Those of you guys that took digital electronics with me, so you should be familiar. We did a 60-second timer and things like that. Okay. And remember, just how those work for a pulse timer. We will be using pulse timers in PLC. So it pulses on for a specific amount of time and then turns off, and then pulses on for a specific amount of time and turns off. Pulses on for a specific amount of time and turns off. Okay, so that's what a pulse timer does. You can use a pulse timer for like an audible alarm or things like that, or we might use pulse timers when we're emergency vehicles, right? When you want to do red and blue for flashing lights, different things like that. So you pulse, blue for a second, then red for a second, blue for a second, red for a second. All right, even the audible, because alarms have two tones, essentially. So you pulse one tone for a second, then another tone for a second, another tone for a second, another tone. So hopefully that helps you understand what a pulse timer is. And then we have a one-shot timer. All right, it's just on for this specific time, and then it's done. So that's called a one-shot timer. All right, and then you got to reset it if you want to use it again. Okay, it's not one and throw it away sort of thing. It's just a one shot for that specific task when we do it. All right, this one we're going to use more in our labs. All right, we have 11-pin timers and things like that. All right, there's an 8-pin timer as well, and that's really just more the internal connections of the timer piece. You can still do the adjustments. You can see the switches on the top of the timer here. Normally that'll plug in and kind of face out towards you, and then you can see it tells you how to make the connections and wire things up on the outside of it, so that you can go to your start switch or things like that, what the power needs to be coming in and what pins those go to. All right, so that's the wiring diagram on it for all the pins. So that's just a pin timer. You kind of plug it in and set it how you want to go. You guys will see in lab when we do that one as well. Okay, so this is just an example here of a schematic where we're using an off delay timer using a pneumatic timer. Okay, and how the pneumatic timer goes. Okay, so remember the TR, that's the off delay timer that's sitting right there. Okay, and then it indicates the pneumatic timer piece. Okay, so that's kind of where the bypass goes as you see through the schematic. Alright, so this way is where we are modifying the off delay timer, okay, and this is using the electronic timer. So remember, if we step back a couple slides real quick and you take a look at those pin numbers, okay, those are relevant to how they go on the schematic here. Okay, so this is our relay. TR is for like timer relay. Okay, so anytime we see TR, it's a timer relay. Okay, and then we have to distinguish on the symbol if it's on delay, off delay, or things like that. So notice on this schematic the TR, the on delay timer symbol on the rung 2, right, has pins 1 and pin 3, and then notice actually around the contactor for the motor 1, right, is 2, 5, 6, and 10. So we can go back and look. Oops, I went the wrong direction. We can go back and look on the timer, and it's showing you exactly where those pins are going and what's getting what. Okay, so there's a way of using a timer there for the motor. Okay, now this is just more Allen Bradley stuff. I know a lot of the other stuff we talk about PLC wise, This is the Allen Bradley timer. I believe we use the Dayton timer. This is the Dayton timer right here. Dayton and Allen Bradley, guys, they're just names, just like Siemens is. They're all companies that produce electrical equipment. So if we were to do the same schematic, Allen Bradley, all right, and our PLCs that we have are Allen Bradley and things like that. Really the difference here is the pin and the contact number. So if we look at the Dayton, right, we're using 2, 5, 6, and 10 for the control piece on the actual timer there. Here we're only using 2, 6, and 10. So 5 has been eliminated because it's a common point on this one. And that's kind of like the nuances about proprietary equipment. Do I use Allen Bradley? Do I use Siemens? Do I use Dayton? Do I use Rockwell, which is still kind of Allen Bradley, or things like that? How well does that equipment work with each other, and understanding how different equipment needs to be wired up differently because it's proprietary. They do the same task, but one might work a little differently than the other. Alright guys, well that's all I got for timing relay, so hopefully that helps you understand. PLC wise in that class, that'll help you understand timing as well, because we actually program a stoplight and time delays and all those different things. And we wait for lights to turn on and off and that sort of thing. So even if you took digital electronics with me, most likely you already did a stoplight, and we did a time delay because we used a divide by 2 type timer because we used flip-flops, all right, and we used a ripple effect sort of thing as it goes through. So we used asynchronous flip-flops to help do that design for timing. All right, but as usual, shoot me an email or let me know if you got a team meet or Zoom meet. Else, guys, have a great day. We'll see you in class.